Implicit differentiation 2. Find the equation of the tangent line to the curve given by log of xy plus 3y squared plus x squared e to the y minus 1 equals 4 at 1, 1. Strategy: differentiate implicitly with respect to x. Before we start, let's do some review. ddx of log of g of x is 1 over the inside, 1 over g of x, times the derivative of the inside, that's g prime of x. ddx of y squared is 2y dy dx. ddx of e to the g of x is e to the g of x times g prime of x. And that's the chain rule. ddx of xy, apply the product rule, derivative of x is 1 times y plus x times dy dx. E to the 0 is 1. Log of 1 is 0. Log of e is 1. E to the power of ln x is x. ln of e to the x is also x. Okay, let's begin. So we have ddx of log of xy plus 3y squared plus x squared e to the y minus 1 is equal to 4. The first thing is to put an arrow wherever you see a y. This will count the number of derivatives that will come out after you differentiate. This way we don't leave anything behind. Derivative of log of xy, that's 1 over the inside, 1 over xy, times the derivative of the inside, that's going to be 1 times y, plus dy dx times x, plus derivative of 3y squared, that's going to be 6y dy dx. And now we're going to apply the product rule here, and that's going to be derivative of x squared is 2x e to the y minus 1 plus, leave x squared unchanged, and differentiate this term. That's e to the y minus 1 times the derivative of the exponent, that's dy dx. And differentiate 4, we just get 0. Okay, let's plug in x equals 1, plug x equals 1, y equals 1, and we're going to solve for dy dx. We get 1 over 1 times 1 plus dy dx plus y is 1, so you get 6 dy dx. X is 1, so you get 2. And plug in y equals 1 here, and you get e to the 1 minus 1. And e to the 0 is just 1. So that's going to be times 1. Plus 1 squared is 1. E to the 0 is 1 again, times dy dx is equal to 0. Let's clean this up. And what do we get? We get 1 plus dy dx plus 6 dy dx plus 2 plus dy dx is equal to 0. Okay, if we add up all the dy dx's, we have 1, 6, 7, 8. So we have 8 dy dx. 8 dy dx is equal to negative 3. dy dx is equal to minus 3 over 8. Okay, this is the slope of the tangent line. Let's draw a diagram to illustrate what we have found. Okay, here is the y-axis. Here is the x-axis. Here is the point, say, 1, 1 here. And the slope is negative. That means the function must be decreasing left to right. So I'm going to draw an arbitrary function that looks like this. Here's x, y, the origin, and here is the tangent line. What we have found is the slope of this tangent line. M is equal to minus 3 over 8. However, the question asks for finding the equation of tangent lines. So x equals 1, y equals 1, m is equal to minus 3 over 8. You can either use the y equals mx plus b form, or alternatively, you can use the point slope for y minus y1 is m times x minus x1. I will use this one. y minus 1, its slope is negative 3 over 8 times x minus 1. If we simplify this, we will get y is equal to minus 3 over 8x plus 3 over 8 plus 1, that's going to be 11 over 8. And that's the equation of tangent line at 1, 1. Okay, now let's add a part B to the question. Approximate y value when x is equal to 0.95. When x is 0.95, the y value is going to be on the curve, but we're going to approximate it with the point on the tangent line. We can just as easily plug x equals 0.95 in here and get the approximate y value, because this is really the linear approximation right here. But we're going to use the formula for linear approximation just so that we have some practice doing that. L of x is f of a plus f prime of a times x minus a. And the value of a is 1. F of a is 1, and m is minus 3 over 8. So what we get is 1 plus f prime of a, that's the slope, we found that earlier, minus 3 over 8. And x is, what is our x? X is 0.95. And that's 0.95 minus 1. If we evaluate this, we're going to get L of 0.95 is equal to 1.01875. And that's this point here, 1.01875. All right, thanks.